This has been sent to me at no cost by Keysight via Daniel Bogdanoff. You may have heard that name. Here's the face of Keysight on their YouTube channel. So now we need to go over to the calibrator and actually check this thing out. Check all the things like DC volts, DC current, AC current, and resistance, and frequency. We can check all those over at the calibrator. So let's go do that. To the calibrator. Right, here we are at the calibrator. I'm going to do DC millivolts first, and I'll work all the way up for the volts range. Then I'll do AC, and then we'll do probably current, and then resistance, or something like that, in that kind of sequence. So make sure we stick around and see what this thing looks like in all those different options. So DC volts, will turn the output on here, so we're floating around. So set to 100 microvolts range on here right now. And their output, this is going to settle down a little bit. Temperature's come up slightly now, it's now like 21.6. It's still slightly below that recommended range, like 23 degrees. It's a couple of degrees out really from where we should be if we're doing this calibration type testing, but it's probably close enough to give us an indication. So let's do 100 microvolts. There we go. You're getting 107. So it's very slightly out. It's got a bit of a null reading there really. It's not quite doing zero. And I can change the polarity on the meter here. So it's 0, positive and negative, and it didn't change. So this has got a bit of erroneous reading going on here. So negative 100 microvolts. Yeah, not quite getting down there. Getting minus 0.088, and do positive just slightly the other way. So that's a little bit interesting. Okay, so let's do 1 millivolt. That's okay. 11 counts out. Yeah. 10 millivolts. 11 counts out. 100 millivolts. 2 counts out, which is looking a lot better. So now let's go to the volts range. 2, 3 counts out there. So 1 volt, 1 or 2 counts out. 10 volts. Basically perfect, as it was with the PDVS2 Mini. So 100 volts, a couple of counts out maybe 1 count. It's got a bit of settling time there. I think it does have some built-in smoothing, so I think it does affect the readings very slightly, but it's also got the smoothing which is turned off. But I think there's still some kind of smoothing going on there. There we go, so it's just back there now. Just flicking 100 just then. Okay, so let's go a bit higher. Looks like there's a few counts out there. About 5 counts out. This has got 600 volt range on DC. So this is right at the top of that range, so 6 counts out there. And then it's got 1000 volt range. Let's do 100. Yeah, that's alright, it's 1 count out. And 1000. 1000's a couple of counts out. That's alright. So I sort of come back and just recheck this millivolt range. And as per the spec, which is here, the upper limit is 60.04. I'm getting 60.01. Well, I'll call it 02, I suppose. So that's actually well within spec at the top end of the range. If I go down a bit more, because it's only a 60 millivolt range, it doesn't go any lower than that. So 6 millivolts is, slightly out as well. Similar kind of amount. So it looks like it's got a very slight offset there. So 1 millivolt range, so 600 microvolts. Very similar offset. And 60 microvolts, same kind of offset. So if I put this to 0, there's that offset there. Okay, we can actually be sure this is not just a calibrator quirk. Could be, by shorting out these input terminals. So here's a short, just stick it across the terminals here. No difference. So it's not like I skewed output from the calibrator, it is actually very slightly out. So that's the measure, AC millivolts now. So it's just settling down, so I just changed it around and just turned it on, so it's got a bit of settling there going on. This is set at 1 kilohertz right now. We'll probably try some different frequencies on it like I always do. Just give it some time to settle down. See, it's still dropping very slightly there. Let's do 1 millivolt. And that's still got that offset there, which is fine. So we've also got this low pass filter mode. Now the low pass filter is supposed to be a 1 kilohertz low pass filter. Just turn it on. There we go. It knocked that signal back quite a bit. So that's obviously working okay. So 10 millivolts. Again, still got a slight offset here. Is it in spec? Let's find out. Now, of course, this is AC. It is frequency dependent because it's reactive. So I need to do a couple of checks at different frequencies, that sort of stuff. So we'll go through, then we'll come back down again and do some other checks. We'll check the accuracy after that. So 100 millivolts, a little bit of settling time going on. So the accuracy of this thing, the specs, actually vary with frequency on AC, as it does with, I think, DC as well. It depends on the range you're in as well. The actual accuracy spec changes quite a lot depending on which range you're in. It'll be the same with AC as well. So let's go to volts AC. See what this settles down to. Hopefully it gets closer than that. It does. Let's go to 0, just to zero it out. See what we get there with no filtering and stuff. Yeah, still setting. I'll come back in a second. Setting's about sort of 14 or so on the count there, so that's not too bad. It's got the same kind of offset the other one did on DC. So 100 millivolts on the volts range. It's a little bit out there. At 1 kilohertz, it's all based on 60 range, so it's all based on full scale at each range. Come back and do 60 all the way down, I think. I just want to check basic measurements on this first. So 1 volt, yeah, slight offset still. Number of counts, 10 volt again, slight offset there. So there's 100 volts, still setting down a little bit, but it's basically there. Again, it's got a bit of an offset, which is interesting. Let's go down to say 400, go to 1000 volt range. Yes, still slight offset there. It's quite interesting. I would be expecting better than that, to be honest. 500. That one's reading slightly low. Setting time is going to get closer. And 600. That's a bit further out as well. 700. That's next range up. It's got a 1000 volt range. Yeah, that's the reading down there. As is that one. As is that one. Interesting. Probably to do with frequency though, because of the voltage is involved. So let's change this to a full range scale and come back down again. 600 volt range, as we saw just now. We're getting that, half a volt out. So 60 volts. So 60 volts, we're out a little bit there. Let's have a look. AC volts, 60 volts at 1 kilohertz. Measured value apparently was 59.955. So 0.01 difference between their calibrator and mine. Interesting. Well within spec. So 6 volts, and apparently the measured value was 5.9935. So this is measuring above their calibrator in this case. Yeah, still within spec, so that's fine. That looks good. So 600 millivolts. Doesn't actually have a spec for that. Well, it doesn't actually have a reading for that on the volt range. So back to millivolt range again. And apparently it's 600.11 on their measurement. And I'm getting, well, yeah, I'm getting a perfect reading basically. That's looking really good there. I'll try different frequencies, like I said. I'll come down, change the frequency and go back up again. It's going to be involved. AC measurements can be involved, especially when they've got this much broadband on them. This is supposed to be like 20 hertz through to 10 megahertz. So yeah, that's a lot to test. Anyway, 60 millivolts. I'll say about 9 counts out. That's actually agreeing with their calibrator. That's exactly the same as what they got on their calibration. So that's good. 6 millivolts, which they don't have a calibration for. So obviously didn't calibrate 6 millivolts. That's quite common for AC. Often the very bottom end isn't actually calibrated. They go to like a low point, don't actually go right down to 0 because AC can be problematic trying to read it. So within 9 counts, it's probably fine. 600 microvolts. Yeah, well, that's actually looking alright. So let's change frequencies. So 100 hertz. That looks really good. Perfect, in fact. May change slightly, but certainly might actually go down. Yes, it did. Okay. So 6 millivolts, 12 counts up, 11 counts. Might settle to be closer still. Yeah, still setting to be closer. 60 millivolts at 100 hertz. They actually did 45 hertz, not 100 hertz. So maybe I should actually go to 45 hertz. This matched their test, so it's exactly the same. So they got 60.018 and I'm getting 60.014. That's pretty good. And 600 millivolts. Theirs is 600.15 and I'm actually doing slightly better than that. 600.06. and now at 6 volts I need to change ranges. So 6 volts at 45 Hertz, and that's 5.9954. 60 volts at 45, that's 59.955. It's going to settle to be about the same. Yep, it's looking pretty good. I'm certainly verifying that their calibration looks like it's bang on, as you would expect. 600 volts at 45 Hertz, and theirs is 599.53. So it's just stabilising to get closer. Again, looking pretty damn good. Yep, so it's stabilised to be pretty close. Nice. 4 counts out compared to what they got. So let's do 20 kilohertz. 600 volts. They've only got 20 kilohertz and 30 kilohertz at different voltages. They actually have it at 600 volts, which is interesting. They've only got 10 kilohertz, 600 volts. So 300 volts in the 600 volt range at 20 kilohertz is 301.07. So I'm about 10 counts out there, 9 counts out thereabouts. And 320 volts, for some reason they got that there as well. 30 kilohertz, that's 321.95 on their report here, and that's 322.05. Again, I'm about 10 counts out there. They're still well within spec, regardless. Okay, so I've now changed to 60 volts and 100 kilohertz, which is another frequency they've got here. It's got 100 kilohertz at 60 and 6 volts, so we'll check that. And theirs is 59.392, and I'm getting 401. So 9 counts out from theirs. That's alright. Go 6 volts, do the same test. So 6 volts at 100 kilohertz, their test is 5.981. Look how close we are here. 3 counts out. Oh, 2 counts out, it's getting better. As it's stabilising. So yeah, we're looking like we're only about 2 counts out there compared to what they got. That's good. Now I'm going to go down to 600 millivolts, still at 100 kilohertz. And on the volts range we're out a little bit here, but because we're on volts, let's go to millivolts, which is the one it's supposed to be in for this test. And they got 598.64. So that's fairly different now, but the spec is 568 through to 631, so it was still well within spec. No worries at all there. Cabling and the reactance stuff like that will have an effect. Just getting 60 millivolts, 100 kilohertz, and this is reporting 59.94. We're actually 10 above that, but that's okay. It's still well within spec. That's actually pretty good. So I'll just come over to frequency whilst I'm still in the AC mode, and we'll check the frequencies out. So I've got it set to 100 kilohertz. We're basically 1 count out there. I'm doing 100 millivolts input as well, so it's pretty low levels. If I do 10 millivolts, does it come up? Yeah, it kind of drops off there. So 100 millivolts is like the bottom end. Let's do 1 meg. That's dropped off. Let's do 1 volt. There we go. It's there. You can read that. That's fine. So let's go down to 1 kilohertz. Go to 100 millivolts again. I'd like to see what the thresholds are. So yeah, 1 kilohertz is just 1 count down. 100 hertz, 1 count down. Can't complain about that really, can you? That's pretty good. And I thought I'd show you the dual function. So I've just gone into millivolts AC over here, held the dual button down, so it did the dual display. So we've got the frequency over here and the voltage over here. I believe there's also some other options in here. So that swaps it over. Milliseconds and duty cycle. Now, could my calibrated duty cycle be slightly out? Potentially. I think I have actually tested it, if I remember rightly. I've actually put my scope on it, actually measured it. I think it was okay. It was very close. Oh, let's measure resistance. I've got this set up already. Doing 10.42. Slightly out, but not much. I mean, the trouble with this kind of measurement is that when you're doing low ohms, any kind of contact resistance or lead resistance, or even within the instrument, can cause a very slight offset there. So with 50 milliohms out, I mean, it's okay. So let's go next one up. 100.42. I mean, I could probably null it out and fix it, but I'm not going to bother doing that. There we go. This one's looking pretty good. Couple of counts out. 1k, 10k, looking just about perfect actually. It's probably a rounding thing here with a 6, 100k. Again, could be a rounding thing with that 5.4 here. So it could be rounding up slightly, but that's basically bang on. 1 meg is perfect. No worries there. 10 meg. Look at that. Basically perfect. Just one count here. And it may even settle down. When you get to this high resistances, it's actually quite hard to measure them. And even doing 2 wire isn't great. So, you know, this sort of thing you need 4 wire for already. But in this instance, it's doing okay. Can't complain about that. 100 meg, can it do it? Yes, it can. It's even really close. Look at that, 1 count out. That's actually very good. Very few meters can actually read this. Right, let's try doing current now. So I've changed it over to be current setup. DC amps. I'm going to do microamps first and see how we go. We've got the microamps range. I have to be really careful not to exceed 440 milliamps on the fuse. I think it can go slightly higher than that, but not by much. You know, I'll sort of show you that down there. Okay, so just watch out for that if you're doing these kinds of things yourself. Check to make sure you don't overload it. So let's have a look. 100 microamps. Turn the output on. That will always helps. Here we go. 100 microamps. We're out by 5 counts. This is do a 0 on that. It should still be 0. Yeah, 0.3. It's got a small offset here. I could null that out and get it better, but I'm not going to leave that as it is. I'm not going to do any nulling. So it's actual values as it reads it. So 4 counts out. That's alright, 100 microamps. So 1 milliamp. Look at that. That's really good. 1 count out there. 10 milliamps. It's taking a little while to find it. There we go. Got there in the end. 5 counts out. I'm actually tempted to go to the top end of these scales and check the calibrations as well. 100 milliamps. I have to be careful I don't go to 1 amp scale. That could be bad. So 100 milliamps, and there we go. A couple of counts out. Right. So I'm going to go to 600. Oh, look, 1 count out. It's getting better. So I'm going to go to 600. And it can take a small overload. It's perfect now. There we go. Setting down. I'll do 600 and 60 and then 6, and we'll see what we get on these ranges here, and to see how that compares to the calibration data. At 500 milliamps, it's basically bang on. Now the actual calibration data here is done at 440 milliamps in the 600 milliamp range. So let's do that. 440 milliamps, and it reported 439.98. So we're about 5 counts higher than what they got, which is fine. So let's go down to the next range down. So 60 milliamps, and I actually did a 60 milliamp range there. So 60 milliamps, we've got 59.998. So we've got a bit of a difference here on this particular range, but it's still within spec. The spec is 60.08 as the top end, so that's fine. 6 milliamps, and it's reported exactly 6 on their test, so I'm 5 counts down from that, which is, what's that, 500 microamps. Can't complain about that. So 600 microamps. They've got 600.03 on their test here. Let's see what ours settles down to. 600.09. So 6 counts out. That's fine. What I'm going to do now is do the AC current, because it's the same lead setup. Then I have to change the leads and change the configuration, do high currents. Okay, so we'll just do that because it's easier right now. At AC microamps, which is what we're currently on, 0 is reading 0, 100 Hertz. Now their tests were at say 20 Hertz, 45 Hertz. So we're going to do 45 Hertz again because that's what we used before. Although 1 kilohertz might be cleaner. But we'll do 45. Okay, so 0 is reading 0. So we're doing 100 microamps. Got to change the meter around. So let's change the meter to AC. So there we go, 45 Hertz, 100 microamps, AC mode, 99.9 something, and our test here, 599. This is at 600 microamps. It's like, it does top end of the range, doesn't do this low down. So we'll do 600 in a second. That's looking right. It's only 5 counts out. So 1 milliamp, it's bang on. So let's go down to 600 to compare it against the calibration data. So that's 600 microamps. And so what I say, they got 599.13. so about 17 high from that one. That's alright, I suppose. 6 milliamps, same frequency, 59925. Again, we're slightly high there, about 10 counts high-ish. Setting to be better. It's getting better. So again, very close. No worries at all, well within spec. So 60 milliamps at 45 Hz. Their data is 59.926. Oh, look at that. They're basically bang on there. That's pretty good. And 600 milliamps, they've actually gone down to 440 again. So 440 at 45 Hz, they've got 439.72. So we're very slightly below that. But that's okay. It's still well within spec. No worries at all. Right, so here we are, set up for doing current. Got it set for DC now. On the amps range over here, amps jack over here, as it should be. I've set this up on my Valhalla 2500 EP. We're just going to do up to 10 amps. Well, actually do about 12 amps, I think. This is something I repaired previously. I did a video on this. If you're interested in watching that repair video, go and check that out. It's in my repair playlist. It's in there. Just look for the Valhalla. You can probably do a search of Valhalla 2500 EP and it will show up in the YouTube search anyway. Because in reality, how many of these things are going to be on YouTube? Not many. Anyway, so basically what this does, this takes an input from my calibrator over here, converts this into a current. We've got it set to the 1 amp range, so when I put in 1 volt, I should get 1 amp. And I'm currently putting in 0 volts, so 0 amps are coming out. Hopefully you can see that okay. And I'll turn the backlight on, is that better? It is better. Okay. 1 volt. And yet we're 5 counts down there. That's alright. 5 counts down on current. So that's not too bad. Let me just find the details for that. So this is on a 6 amp range. So I could actually go up to a higher level there. When I first powered all this stuff up, it's actually looking closer than this. But now there could be some error in the calibrator output going through this unit. This isn't perfect. You know, it does have some error inherent in this. So you have to accumulate the calibrator error with this error, with the multimeter error. So being 6 counts down at 1 amp, yeah, I'm not too worried about that. That's 600 milliamps. Yep, that's looking okay. So we turn this output off, put that to standby, go to the 10 amp range. Let's go down to here, so don't go straight to 10 amps. Put it back into operate mode. That's the 100 millivolts in, so 1/10 of 10 amps. And we're getting 1 amp coming out. That's exactly right, that's exactly what it should be. So that's now increased this by dropping this down to say 6 there. Go up a range, so it should be 6 amps. Yep, and that should be doing 6.0016 according to Keysight. Look how close we are to that. Watch it, stabilizers. Obviously with the shunt within the meter, that'll be heating up, so that will change. As it heats up, it will expand slightly, and so it will give a higher voltage drop because the resistance will increase, and therefore this will gradually drift upwards. So that's exactly what it's doing. So that's fine to me. So now let's do 10 amps. Here we go. So 10 amps, and we've got 10.001 from Keysight. Wow, look at that, we're basically there. And with heating, it probably will get there. Here we go, 10 amps exactly. Happy with that. So for some reason, when I'm trying to drive the Valhalla with the Datron calibrator to generate the AC signals, it's not liking it. Anything above 1 amp, it's just not liking it. So I've decided to come back down here. This can generate up to 1.9 amps. So we'll give this a go with this. Doing 45 Hz still, and we'll do it here instead. So 1 amp AC at 45 Hz, we're getting exactly 1 amp. 1 digit down maybe. And the most I can do is 1.9 amps. And there we go. Very slightly down there. But yeah, seems accurate enough, doesn't it? Seems fine. As you would expect. So, thank you very much, Daniel, for sending this to me from Keysight. Much appreciated. Great little multimeter to have around. Although it's not that little. I was tempted to do a teardown on this, but this video's got long enough, so I'm not going to do a teardown because this video's already way too long. But hopefully I've sort of conveyed the capabilities as multimeter. It's got functions and stuff which I haven't covered, such as the computer interface and the logging and things like that. I may do a follow-up video with this if there's demand, that people actually want to see me trying the logging out or trying to get the computer interface working and doing a teardown. Maybe I'll do a part 2 video, just do a follow-up to this, just to complete it. So again, thank you much, Daniel. Much appreciated. Don't forget to click like and subscribe if you like this kind of videos. I'll catch you later. Bye.